Students, industry professionals and researchers, welcome to the course on material informatics. This is the first lecture. Myself is Professor Krishan Biswas from IIT Kanpur. Today we are going to discuss about the aspect of the course. That means how what the course content, different materials, other aspects of the course, how evaluation will be done, and then in the latter part I will talk about something about the basic aspects of material informatics. As you know, this is the course which is getting offered for the first time. So, we are going to take time to understand what is material informatics, why we are doing that, what are the advantages of taking a course on material informatics and so on. So, first of all, this is a massive open online course, we call a MOOC course offered on NPTEL forum, and this is a course which is known as Introductory Material Informatics. That means, this is the very first step to understand what is material informatics, material data science is about. And we have two instructors, as I said, one is myself. My name is Krishan Biswas, I am from IIT Kanpur. We have another instructor, Professor Pratik Ray, he is from IIT Ropar. You can look at the course introductions. We have already discussed about the various aspects of the course, but I am again going to talk about it in a detailed manner. So, what are the course outline? Initially, I am going to provide you some introductory concepts of this course, which is on material informatics, some general information, and then we will talk about statistics, regression analysis, probability, classification, and how the data are handled. Because informatics is interlinked with machine learning and deep learning, but there are certain differences between machine learning and deep learning and the informatics. Nonetheless, mathematical formalisms which are used in the statistical tools will remain same, like regression, Bayesian concept in probability, classification problems like SVM, decision tree and many other aspects, and data handling. And after that, after this introduction of the subject, we will talk about what is the initial aspects of material informatics. That means, how material informatics can be put into action. That is what is called the initial glimpse of the material informatics, and I am going to teach on that aspects. So, we are going to talk about various important techniques which cannot be covered in machine learning or deep learning course, like gradient descent, regularization and solvers and regressions, and various other ML models which I have not listed down here, but details are available in the course website. So, once you know this, then you have to use details of the various kinds of machine learning models or applications like some linear models, SVM, decision trees, Bayesian concept, neural networks, clustering, and finally, what kind of models which you select, what are the visualization techniques and transformations. So, this will give a detailed aspects of how machine learning models can be applied in informatics course. Then we will go into the details of the data repositories and featureizations. Today I will talk about the material data, what are the data sources we have, and how we can use this data for mapping of materials. And some aspect of this course will be taught also by Dr. Pratik Ray, that is on periodic table, elemental descriptors, principles of featureizations, where we are going to spend a lot of time. There are two types of material design, one is called intrinsic design and is called extrinsic design. In case of intrinsic designs, we are talking about composition as the main variable or main feature to control the material properties. In case of steels, you can have mild steel or you can have alloy steels. Mild steel contains only carbon rather than iron, but alloy steel contains various alloying elements. So, why do you change the compositions when you want to have different kind of steels, and how this can be used as a feature. But in case of extrinsic materials design, we can have a single composition where you can have different kinds of heat treatments or processing conditions where we can alter the microstructure and same the material properties. So, there we are going to bring in lot of other features like thermodynamic features, kinetic features into the situations. So, that is why featuration is something which is quite extensive in case of material in informatics course, unlike in other courses. So, this will be taught both by myself as well as by the Professor Ray in this part of the course. Then next two parts will be predominantly taught by Professor Pratik Ray, and that is actually about the structure of materials and microscopic informatics. I am going to give a brief glimpse today also. We know that materials are hierarchical natures, especially the microstructures, and you can have different length scale of microstructure starting from optical microscopy to about high resolution TM or high resolution transient microscopy. So, how we can bring in that aspects to predict intrinsic and extrinsic material properties, how we can use crystal structures, molecular fingerprints, microstructures as important features of informatics, because we can obtain information from microstructure also. That is what we will talk about today in the later part of the class. And finally, we are going to also discuss the PSP linkage. Now, what is that? The processing, structure and properties linkage, which is the key thing of material science. It is not same if we talk about data informatics in other courses, because material design is basically based on these correlation: processing, structure and properties. I can write down also. So, we can talk about processing, which is very important concept, that is the first P, and this processing determines the structure. Structure may be crystal structure, phase structure, microstructure, and finally that determines the properties and performance or performances of the material. So, these links are very important when you talk about material design. At the end, Professor Ray will talk about material informatics, how it can be done thoughtfully, like what kind of decision making you will use and how to interpret that, and how can you combine the informatics with physics based models. You can generate synthetic data, do a lot of modeling, which you will do. I will talk about some case studies also, and how can you use combinatorial material processing, high throughput characterizations also. So, that is some of the different parts of the course. At the end, we will talk about some future challenges and future directions also. So, that is in a nutshell the course structure looks like, and if I want to give a one page summary of that, first we will talk about some introductory concepts, then I will talk about initial glimpse of the material informatics, and after that I will talk about some material machine learning models and applications. This will be followed by data repositories and featureations, where I am going to spend a lot of time, and finally structure of material and microstructural informatics, as well as how material informatics decisions can be done thoughtfully. We will be talking about it. So, this is in a nutshell what is the course outline looks like. What the prerequisite requires? We do not require any prerequisite, except you must have some basic knowledge of the material science. That means how materials are made, what are the basic structures of the materials, and how properties are determined, what are the different properties we are going to talk about it. Other than that, you do not need much information. If you are from other backgrounds, lot for material science like me, you are for mechanical engineering, chemical engineering, civil engineering, physics, chemistry, even biology, and you have inclination to do this course, and you know some basic concept of material science, this is for you, because data science or informatics are going to play important role in the next 5 to 10 years time. As you know, in biology, in computer science, data science is very important. In material science, we do not talk much about it, but here I am going to, or we are going to talk about it, how this can be used for your benefit, and our job is to create the future manpower, so that they can understand the subject and do whatever required in the process. So, this is a detailed course line. I do not want to talk into details about that. Detail means these are the subtopics, different kinds of subtopics discussed. Like in case of the introduction, we are going to talk about importance of data informatics, why it is important for design. We will talk about some historical aspects of that maybe in the next class, and then we will go into the other aspect like statistical aspects, regression, probability, data handling. We will spend 2 lectures, as you can see, how we can use different kinds of tools like matplotlib, data cleaning and Python scripts. By the way, as a part of the course, we are also going to teach you, how to use these, Python scripts. Some of the TAs, especially the teaching assistants, they will talk about how Python scripts can be used and effectively. And if you have already some knowledge of Python, that is basically very good, that can be utilized nicely. And then we will talk about various kinds of alert designing, learning rates, regularization solvers like L1, 2 or L2, L1 solvers in case of different kinds of techniques. We will talk about it, let us not discuss today all everything. So, that is the details course structure which you can get into it. Okay. What are the books and references? There are 4 books I have listed here, and I put the pictures also the cover page of the book. So, first one is the Introduction to Materials Informatics by T. Zhang, very recent book, 2025, published in February or March, and you can have a copy of that. It is not very expensive, it is almost 7,000 rupees is the cost of the book, very good book either way. And if you really want to know details about the informatics, how the methods, tools, applications are there, this is the book which you follow, which is edited by the 4 scientists. And Krishnarajan, he has written a book on material informatics, molecules, crystals and beyonds. And lastly, there is another book which is very important, Material Discovery and Design, edited by the again 4 scientists, and these books I will use in different ways as my lectures, but majority of my topics will be covered from the first book, which is the basic book on material informatics. So, as you can see, this book has come only in 2025. These are very new books, our topics is also very new. So, we are learning these topics, and that is the idea, to give an insight of the material informatics, so that you can use it, apply it for your various kinds of design aspects. So, we will have teaching assistants, we have 2 TAs, I believe more than 2, maybe 3 TAs, we are yet to decide on that. 3 TAs who can assist you in assignments, forum answers and lot of interactions. Please to use this to interact with the TAs, and obviously for every week we have assignment problem to be solved, and you need to discuss with the TAs if you have any doubt, any clarification required. You can also write to me, but TAs are the front face of the interaction. That means they are going to interact with you more often. You can write comments, you can write questions. If you do not understand certain aspects, we can also discuss over the discussion forums. In addition, we have one PMRFTA who will discuss and provide you hands-on training. So, that means PMRFTA which you are going to have it will have some idea about this Python scripts, and hence he will provide you lot of hands-on training. Obviously, he cannot or she cannot give you everything what you want, but if you have any questions, any aspects of hands-on training, you can always discuss with that. How this will be evaluated? The detailed evaluation process is given in the course website. I do not want to get into all the details about the marks, percentage of marks to be obtained for passing this course, but there will be 12 assignments because there are 12 quiz courses, including one 0 assignment. That means at the beginning of the course, there will be a very simple assignment which is called 0-week assignment, and at the end there will be one exam, that is called end-sem exam, and you need to perform well in this exam and quizzes as assignments you get to pass this course, or you have to get a certificate of this. So, that is the evaluation process which you are going to use it for the purpose of your benefits. So, but let me tell you again, this TAs are going to provide you various aspects of how the assignments are solved, because assignments carry a lot of marks, and assignments are sometimes the basic questionnaires which can be again used in the end-sem exam also. So, please to solve the assignments in a very systematic manner without any delay and submit it in the time frame provided, so that you do not miss it out. This is something which people always take lightly, but I am telling you because assignments are key for your performance. You need to solve LBS assignments and upload the answers as in the timeline given as per the NPTEL formats. So, why this course is relevant? Okay, you must be thinking, many of you must be thinking, but the name of the course in informatics means data science basically. How do you handle data? And materials are omnipresent and all pervasive. You cannot have life without materials, right? Whatever you see is material. This pen has a lot of materials. You can see here the body of the pen, the tip of the pen, even the electronically writing also. It's all consisting of material actually. And because they serve the crucial building blocks in the technological aspects as well as innovations. And the impact on life and society is extensive, right? If you change the materials, your life changes. Today you have a lot of technological aspects you are using day to day life. How these technological innovations have came into practice is because of the discovery in material science. Obviously, not only that, but material plays a major role in impacting your life and my life as well as society at large. So that's why material science is very important in the history of science and technology. So what the material informatics do? I have listed down in red. First, it does material informatics improves the operational efficiency. What is that? If you want to design some new material for some specific applications, if you can do by simply experiments also, right? That's what we have been doing all the time. But experiments requires time and energy as well as cost. Nowadays, we want speedy discovery of material. We don't want to wait for the experiments to be done for years together and then finally make a conclusion about the material discovery. So, informatics will allow you to hasten or fast, make the thing fast. That improves this operational efficiency of the design and development aspects. That is very important, remember this. It also helps minimizing the waste and lower the cost by optimizing material selection and productions. Very important statement. If you are going to do experiments, many of you may be doing or maybe may have been doing, you know that it takes a lot of energy and time to get an experimental results properly done. There are chances of mistakes. That is why you call the experiment as a trial and error method. Trial and error. We try and learn from errors. Okay, that is what is called a trial and error methods. And in this process, we spend a lot of time and energy. Let me tell you. You can start making a material, you may fail sometime or may succeed. So therefore, there is always a failure. And once you learn from these failures, then only you can be successful in making the material. So therefore, we generate a lot of waste and a lot of money and material are spent, time also spent. So material informatics, we can do everything using these models. So you don't need to do any experiments at the beginning. You can reduce the cost, minimize the waste while designing the material, right? That's the biggest thing. Third thing is the increases sustainability. Why? It enables tracking and optimizing material use. Enable tracking and optimization of material use so that waste can be reduced and environmental impact of the wastage is reduced. You see the material wastage, right? Plastics is the biggest waste we throw on different parts of the also our mother nature, whether it's a river or sea, oceans or landfill, but this waste actually affects our environment extensively. So that can reduce substantially. So it's not only improves operational efficiency, but also helps minimizing the cost as well as waste. At the same time, it allows us to make the world sustainable, because we are doing less experiments, we are generating less waste. These are the critical aspects which you keep in mind when you go through this course. So therefore, in a nutshell, these are the reasons why this course is so important and relevant in today's society. So what can do with material informatics? I will use this small abbreviation MI. MI stands for material informatics. It allows you to do a material selection job, that means matching with the product design. It can also allow you to do various kinds of functional performance study. We can do modeling and simulations for the properties and failure of prediction also. It can allow us to match the materials and processes, very important. And it can also allow you to study the surface performance of material. Once you put a material into use, like this pen which is used in this using this material, how this material is performing, how long this pen can be used, what is the wear and tear of this material, this can be easily matched using material informatics in the service performance. And obviously, we can always compare the efficiency of a particular material in a particular applications and check which is the best efficient material. Then we can also do environmental performance. If I put a material in the real applications, how it is going to affect the environment? It is going to damage it, or it is going to be benign to the environment, or it is going to be neutral to the environment. That can be studied. It can provide solutions for recycling, upcycling and zero waste also. We do not think we can talk about this last one in this course, because that is quite extensive. How can informatics be used to find solution for recycling or upcycling or zero wastage? That is a big topic. Even one course can be made on that topic itself. So, these are the things which we can do with the material informatics. This is not the ones, there are many more, I am not listing out. So, in order to impress you upon, so we will take few examples, right, various examples we will talk about it in these aspects, so that you can get interested how a materials are designed. But before that, let me tell you, material informatics is a relatively new subject, maybe 5 years old, not more than that. But data science is not that new, it is existing for almost 10 to 15 years. But you know, Michael Ashby, I am referring his book, you can see here, Material Selection and Mechanical Design, wrote this book in 1996, almost 25 years ago. At that time, there is no concept of informatics in material science, but he actually first time in the world showed how material informatics or material data can be used for effective design in and select the material for particular applications. So, we will take some examples from his book and we will talk about it. The first example, let me tell you, we will come back to the second part of the lecture. First example is how do you select material for table legs. What kind of table legs we talk about it? You know, this was done by Italian designer Luigi Tavolino. Actually, he was asked to design or conceive a lightweight table for of daring simplicity. These statements are directly taken from the book of Michael Ashby. Basically, it will have a flat sheet of toughened glass. You can see here, this is a flat sheet of toughened glass. And this glass is supported by 4 cylinder unbraced cylindrical legs, okay, we call it. Legs must be solid, that means they must not be hollow, and that is why they must be thin and they must be light also, because you can take the table anywhere you want, that is what. And they must support the tabletop weight or whatever you placed on this table, food or whatever you talk about it. What kind of materials one can recommend for this purpose? That is the question you ask. So, you see, these are the design statements. You want to design a table material or material of a leg of a table rather, in which the legs are slender, lightweight, but must have sufficient strength to take care of the load of the glass or flat sheet of toughened glass as well as anything you can place on it. How do you handle this problem? Well, this can be only handled using a mathematical technique. So, that we will discuss about it, but you understand this is a design problem. This can be simply done by solving some set of equations, or it can be simply done by using informatics. Initially, I will show you how it can be done using the set of equations, but later on I will show you, later on means much later, how this can be solved by informatics problems. So, let me stop this part of the lecture. I hope I have given you an introduction of the course and told you why material informatics is so important why it must be taught and learned by the new generation of the scientists and engineers, so that it can be used for future purposes. Thank you.